Hi everyone, my name is Frédéric. I'm from Toulouse, France, and today I would like to talk to you about teaching critical thinking skills with astronomy. To start with, a few forewords about why we should teach critical thinking skills at school. Well, you know that there are many fake news that are broadcasted by different medias and or social media. And well, astronomy makes no exception, and there are fake news, conspiracy theories around. And I mean, it's not only about debunking them; it's about rather to use them to learn how to think and how to deal with scientific information in general. You have a few examples here: the flat Earth, of course, the moon hoax, HARP, for those who know. For those of you who know it, it's a kind of radar, ionospheric radar, and of course everything about astrology. So first of all, what is critical thinking? Well, according to Kahneman and Tversky, there are two ways of, or two systems of thinking. You have, say, the fast way or the fast line, based on intuition and instinct, and our brain uses this way of thinking like 95% of the time. It's fast, but it's not effective, and it's actually not reliable at all. Then there's a slow mode, the most effortful, most logical. It takes effort to use this second system, say system 2, the rational thinking. And that's the system you use when you say, where should I trust this information, or should I trust what I see or what I hear or what I read? And of course, it takes time. It's a lot of effort. It's very slow, and it's kind of demanding psychologically or intellectually. But we can't run on this system 2 all the time. And part of critical thinking is to make the own decision of using this system 2 or not. Okay. Another way of defining critical thinking is, well, it's my definition, or it's one of my definition, is the ability to say no to your own brain. Okay, so your brain will tend to trick you sometimes, and well, you have to react. So to start with, there's some definition to be given. Defining knowledge, belief, and opinion is very important at this stage. We could define knowledge as the understanding about the subject that one gets by experience or by study. Okay, so scientific method, evaluation, consensus in science is very important to explain to our students. A belief, on the other hand, is rather the feeling of being certain that something exists or is true without any proof, without necessarily having thought about it deeply. An opinion is rather a thought of or judgment about something. The moral is involved here. An opinion may be influenced by belief and or by knowledge. On the illustration here, you have what could be illustrated as a scientific method. You have the facts, and then you try to draw conclusions. And the ideological method would be the other way around. You start with the conclusion that you absolutely want to demonstrate, to prove, and you try to find facts that could support it. Knowledge and opinion may change. I mean, by definition, knowledge is evolving all the time. Could be changed, could be discussed, and they are refutable. Okay. Beliefs are based on intuition or dogmas and are not supposed to be questioned in general. That's a big difference. So to train critical thinking skills, I talked about how science works, which is the first step, I guess. Then there's another step, which is media information literacy. We have many sources of different kind of information, trustful, not trustful, or trustworthy, not trustworthy. And I mean, all those social networks and media may spread fake news and conspiracy theories, so we have to be very cautious with how we deal with information. And to select information that we can trust, we need to better understand how scientific information is produced, by whom, and for what purpose. However, I mean, many people working on critical thinking emphasize the media information literacy. In my opinion, this is not enough to train critical thinking. because there are all those cognitive biases, which are the systematic pattern of deviation from rationality and judgment. I mean, in other words, your brain can trick you. And if you don't use the system to, I just explained earlier, well, you can reach very strange conclusion on what you see and what you hear and listen. And it's important to be aware of those cognitive biases. A very common cognitive bias is to confuse correlation and causality, for example, or to tend to trust rather information that support your own belief or your own knowledge or what you think is true, rather than alternative conclusion or alternative results. Cognitive biases may also trick your own senses. I mean, think of the pareidolia on Mars. I mean, this is basically not a face on Mars made by, I don't know who or what. So remember that you shouldn't trust what you see or what you think you see. An image is not necessarily proof. So why using astronomy to train critical thinking? Well, astronomy is based on robust knowledge, far from hot topics. And this makes a very quiet atmosphere, okay, to train critical thinking. Astronomy is interdisciplinary in nature, so it makes connections between disciplines. And this very bad thing is to have boxes, you know, with different disciplines and topics. And if you don't make connection between all those, well, you can be basically you could trust ideas that you shouldn't. Astronomy is fascinating and enjoys wealth of public affection, so we should make the most of it. And a good way to captivate your student is to play with their misconceptions and cognitive biases. Also, astronomy reveals to be a great means of testing and challenging critical thinking and debunking common beliefs or misconceptions. Think of the shape of the Earth. Why? I mean, the Earth looks flat when we are on it, okay? And what argument should be put forward to demonstrate it's not flat? It's not easy. It's not that easy, for at least for students, depending on the age, of course. The same for astrology. Astrology, you could say, well, it's nonsense. It can't work. Okay, well, just show it doesn't work. And there are two approaches here. Either you give arguments saying that it can't work in theory, and there's the second approach, which you can show that astrology does not work. I mean, the same for birth rate during full moon. There are no more birth during full moons than any other moment of the year. Conspiracy theories are a bit different because you can show that they are rubbish, but it's interesting as well to understand why people trust or agree with those theories. And I cited the moon hoax and the HARP facility, which is supposed to be a weapon. So there are work to do on all those things, and there are a couple of resources I know of. Unfortunately, they are only in French, but there's a set of activity called Astronomy and Critical Thinking, and a book that we have published a year ago or so called Beliefs and Misconception in Astronomy. And all those two are based are not necessarily, they're not telling you what to teach or what to think, but they tell the teachers how to make activities that will lead the students to think by themselves and to reach the conclusion that should be reached. And yeah, okay. Thank you for your attention.